Hello, assalamu alaikum, good morning, good afternoon, good evening, good night. My name is Dr. Muhammad Nurhilman Rabbani, and today, right now, I'm gonna be talking about how to perform the operations of addition, subtraction, scalar multiplication on vectors represented as directed line segments in 2 space, and on vectors represented on Cartesian form in 2 space and 3 space. 2 space means 2 dimension and 3 space means 3 dimension. As you can see, Mr. Sean is the best. So, okay, first things first, the addition. Let's start with the sorry, my handwriting is quite bad. Let's start with the easiest one, the addition of vectors. Addition of vectors. 2 vectors, in fact. 2 vectors, of course. How can you add 1 vector? Of course, 2 vectors. The vector addition, S. S is the vector for the vector. The vector addition S of 2 vectors of S is equal to the addition of the 2 vectors A and vector B, right, is denoted by A plus B. Vector S is the addition of vector A and B, and this is called the sum of A and B, right? This is basically the general rule, not the general rule, but yes, that. Now we can do it geometrically. By doing geometrically, now we're gonna talk about addition of vectors in 2 dimension geometrically, not algebraically, but geometrically. Okay, geometrically means using pictures and illustrations, not numbers and letters. Okay. Now to find the sum, or as some might call it, the resultant of 2 geometric vectors, we place the second vector with its tail on the tip of the first vector, which is the head. Let's say this is vector B, and this is vector A. Now to add vector B and vector A together geometrically in 2 dimension, we place it head to tail. This means we move either vector and put the tail on the head of the other vector, and yeah, let's add A plus B. I'll give you an example. A, okay, vector A geometrically added with vector B. This is not 100% accurate degrees of accuracy, but you'll understand what I'm saying. Like this is vector B. As you can see, head to tail. Okay. Now the resultant of the vector is you draw another line from the first tail, the tail of the first vector, to the head of the second vector. This is the resultant, or the sum of vector A plus B, also known as, in this case, the vector S. Alright. Okay, now we're going to talk about the parallelogram rule. You can also use this rule to add 2 geometric vectors. Okay, let's say we got vector A. Vector A looks something like this. And we got vector B. Okay. Now to add this vector using the parallelogram rule, it's always hard to say that, we position both vectors with their tails at the same point, which means their tails should be at the same point, touching. Let's do that. Position both vectors with the same tails pointing. This is vector B, and this is vector A. We position them with the same, their tails at the same point. Okay. Now we build a parallelogram using both of these sides as such. Now to build this one, I'll use the dotted line. Okay, and then we build a parallelogram as shown, like that. The resultant vector, the resultant vector is given by the diagonal of the parallelogram, starting from the common tail point. This is the resultant vector from here until here. From the tail until it's a diagonal. That's the resultant vector. This is vector A plus B using the parallelogram rule. Okay. Alright, now we're gonna do vector subtraction, the subtraction of two vectors. Now the subtraction operation between two vectors, vector A and vector B, can be understood as a vector addition between the first vector and the opposite of the second vector. Minus. In other words, I can rewrite this as the first vector plus the opposite of the second vector, vector B. But let's say this is vector A and this is vector B. We want to add that we want to do this A minus vector A minus vector B. It says vector A, okay. We're putting this heads to tail. Okay. Add the opposite of vector B. Now the opposite of vector B goes this way, like this. This is the opposite of vector B. Okay, heads to tail. We'll put it to tail, opposite of vector B. This is vector A, and this is negative B. Now the resultant vector is from the tail of the first vector to the head of the last vector. This is vector A minus vector B. And that is the subtraction of two vectors. Okay, now we're going to talk about the multiplication of vectors by a scalar. Vectors by a scalar. Alright. Let's say vector V. By multiplying vector V by a scalar of K, K is a scalar, okay? We obtain a new vector noted K. This multiplied by K, KV. This is new vector. If we multiply vector V by a scalar of K, scalar is any number, 1, 2, 3, 4, any real numbers. By V, we get a new vector called vector KV with the following properties. KV has the same direction as this. KV has the same direction of vector V if K is more than 0, which means if K is a positive number, then KV will have the same direction as vector V. Now if K is less than 0, in other words, if K is a negative number, then the direction will be opposite. The direction of KV will be opposite to the original vector V. Let's draw a vector V. This is vector V. All right. Let's say the vector V has a unit of 5 centimeters. K is equal to 3. Okay. Now we multiply this vector by K, which means 3 times the vector V. 3V. My bad. We want 3V. Okay? So 3V means 3 vector V's. So if we have a unit, we will have a vector that is 15 centimeters long. V, V, V. This means 3 vector V's, which is one whole vector of 15 centimeters. If the vector has a unit, depends on the unit. That is the multiplication of vectors by a scalar. Okay, now we're going to look at the operations of vectors, algebraic vectors in two dimension. Okay, let's talk about the addition of vectors, algebraic vectors in two dimension. We have vector A is equal to AX and AY. And then we have vector B is equal to BX, X coordinate, and vector Y coordinate of vector B. We want to add them together, A plus B. We want to add A and B. We can do this by adding the X coordinates of A and the X coordinate of B to find the new X coordinate, and by adding the Y coordinate of A and Y coordinate of B to find the new Y coordinate of A plus B. Right. Let's use numbers so it's easier. Okay. Let's say we got vector A is 2 and 5. Vector B is equal to 3 and 10. We want to add vector A plus vector B. We add the same coordinate together, so this will be 2 plus 3 is 5, so the X coordinate will be 5. 5 plus 10 is 15. This is the new coordinate of vector A plus B. We can name this vector with any letter, such as vector S. So we just named this vector vector S. Vector S is vector A plus vector B. Remember, add the same coordinates to find the new coordinate of X and Y. Okay, now we're gonna talk about the algebraic vectors in two dimension. Now we're gonna talk about the subtraction of algebraic vectors in two dimension. Okay. Now the difference of 2D two-dimensional algebraic vectors can be written as vector A. Let's say vector A is AX and AY, and vector B is equal to BX and BY. Same thing. If you want A minus B is basically AX minus BX to find the new X coordinate, and AY minus BY to find the new Y coordinate. Now let's use numbers in this, okay, to make it more simpler, because letters are it looks quite complicated, but it's not really, it's really easy. Okay, let's say vector, I'm gonna rub all this. Okay. Let's say vector A has the coordinate 9 and 6, and vector B has the coordinate 12 and 5. We want A minus B. As we've seen earlier, we subtract the coordinates with the x-axis with the x coordinate with the x coordinate of B, and the y coordinate of A with the y coordinate of B. So the answer will be 9 minus 12. 9 minus 12 is minus 3 for the new x-axis, and 6 minus 5 is 1. The y coordinate of A minus the y coordinate of B is 1, and this is the new vector. The vector is the new coordinate for vector A minus vector B. We can name this vector any vector. We can name the vector T to make it look more neat. Okay. All right. Now we're going to talk about the multiplication of algebraic vectors in 2 dimensions. Now, the multiplication of two-dimensional algebraic vector can by scalar number, which means by any number, any real number, really, 1, 2, 3, 4, 5, 6, 7, 8, and the negatives also, is given by, let's use scalar as lambda. Scalar A is equal to, we can write like this: scalar AX and AY. A scalar times the vector A, we can write it as scalar. We times this, we times the scalar by each of the coordinate. Okay. This is easier if we use numbers instead of letters as usual. Let's say vector A is 3 and 6. Okay. And the scalar is, we want to multiply vector A with the number 4. 4A. 4A. So that means 4 times 3 and 6. Okay. So 4A is equal to 4 times 3 is 12, and 4 times 6 is 24. Okay, this is the new. See how easy that is. This is the new coordinate for the vector A. If you multiply it by a scalar of 4, you just multiply each coordinate each coordinate by the scalar. In this case, 4 times 3 and 4 times 6. 4 times 3 to get the x-axis, which is 12, and 4 times 6, 24, to get the y-axis. Okay guys, we went this far. Now we're going to talk about algebraic vectors in 3 dimension, or 3 dimension. First we're going to talk about the addition. The addition of 3D algebraic vectors, okay? The sum, let's say the sum of 2 3D algebraic vectors, vector A is equal to AX, AY, and AZ. Remember, in 3D there are 3 coordinate axes, X, Y, and Z. Vector B, let's say vector B is BX, BY, and BZ. If we want to add these 2 vectors, vector A plus B, same thing, we add the corresponding coordinate axis with the other one, which means vector AX plus BX, AY plus BY, and AZ plus AZ to find each coordinate. Let's do that with numbers, which makes everything easier. Say we got vector A is equal to -2, -4, and -8. And vector B is 5, 10, 15. We want to add vector A and vector B together. Okay? So if we do -2, this is let's call vector A and vector B S. So vector S, which is the addition of the sum of vector A and vector B, is the x coordinate will be -2 plus 5 is 3. And for the y coordinate, y-axis is -4 plus 10 will be 6. And the last axis, which is the z-axis, is -8 plus 15 will be 7. See how easy and simple that is with Dr. Hillman? We got the answer is 3, 6, 7. The addition of algebraic vectors in 3D. Okay, now we're going to talk about the subtraction of 3D algebraic vectors. Subtraction of 3D algebraic vectors. Now it's the same thing as the addition, but this time we subtract from the first vector with the second vector. Let's say vector A will be AX, BY. Sorry, AX, AY, and AZ. And vector B is BX, BY, and BZ. If we want A minus vector B, we minus the each axis. We can write this, it may seem complicated, but it doesn't. So vector A minus vector B is equal to AX minus BX, AY minus BY, and AZ minus BZ. This basically means the first, the AX coordinate minus the BX coordinate. To find the new x coordinate, the y coordinate of A minus the b coordinate, the y coordinate of B to find the new y coordinate, and the z coordinate of A minus the z coordinate of B to find the z coordinate of the new z coordinate. Okay, now let's use numbers to make everything easier. Okay, so we use numbers. We will use numbers. So let's say A is 3. Let's say vector A has the coordinates of 3, 6, 9, and vector B has the coordinate of 4, 5, and 6. We want vector A minus vector B. Okay, now vector A minus vector B is 3 minus 4 is equal to -1. Okay, that's for the x coordinate, the new x coordinate. 6 minus 5 is 1 for the y coordinate. And then 9 minus 6 is 3, the new z coordinate. And that is the subtraction of algebraic vectors in 3D. Okay guys, now we're going to talk about the multiplication. Multiplication of vectors in 3 dimension. Okay, the multiplication of a 3D algebraic vector can be written as vector A, AX, AY, AZ. Okay, with a scalar number. With a scalar, let's say the scalar k. If you multiply this by the scalar k, you will get k times ax, ay, az. We can also write this as kax, kay, and kaz. This just means we multiply each of the coordinates in the vectors x, y, z with the scalar k. Let's use numbers to make it easier because letters are very confusing. So you understand. Let's say we got vector A of 1, 6, and 7. Okay? And we want to multiply vector A, multiply with a scalar of 3. So this means k This means 3a is equal to 3 times the vector a, 7. So 3a is equal to 3 times 1. This is the new coordinate, the answer. 3 times 1 is 3. 3 times 6 is 18. And for the last z coordinate, 3 times 7 is 21. Not 9 plus 10, okay? 3 times 7 is 21. And that's basically it. That's the multiplication of vectors in 3 dimensions. I'm Dr. Muhammad Nur Hillman, and thank you for watching.